Okay, good afternoon, everyone. Those who are watching, I request all of them to please write their names in the chat box so that I can know who all are attending the class. Thank you. So, Varsha and Anchita, are you guys studying together? This is Varsha and Anchita. If you guys have any doubt or any specific topic that you want me to cover, you can post it in the chat box or on the group, or you can send me the personal message on WhatsApp. Okay, Tanay is here, Varsha, Anchita, and Shraddha is here. Anyone else who is attending the class? Okay, I'll wait for one more minute before I start the class. What I'll do is, okay, Shraddha, I'll take, I'll try to solve few questions from there too. But before that, I would like to solve few questions from quadrilaterals also, because quadrilaterals is something which we haven't done that much. So I have discussed many type of quadrilaterals with you, so I will start taking questions based on quadrilaterals. And I'm not solving any or I'm not proving any theorem as such. I use the theorems directly. I request all of you to please go through the book so that you can know how the theorems are proved. Okay, welcome Aditi, Dhruti, great. So is it fine, guys? I mean, I'm not going to prove theorems because this is a revision class. I don't think proving theorem except one or two, like theorem like this, the angle bisector of a parallelogram form a rectangle. This can be directly asked in the question for a 2 marker or something like that. So if anyone wants any particular theorem to be proved, or if you want to understand how a theorem has been proved, you can post that doubt in the chat box. I'll take that up. So I'm starting with quadrilaterals. So okay, great. So I'm starting with parallelogram. Now, what are the properties of parallelogram? So there are few theorems which has been given. First theorem is, suppose you have a parallelogram, something like this, and if you draw a diagonal, so suppose I mark it ABCD, so this diagonal will divide the two halves into congruent triangle. And how it can be proved? This side is common to both, these two sides are equal, these two sides are equal, so you can utilize any one of them, or you can say that this angle, because these two sides are parallel, so this angle and this angle is equal, and then you have two sides equal. So as simple as that. So what I'm trying to say is that, hi Anirudh, oh, okay, Anirudh have also joined, good. So one property is diagonal will divide. Now I'm starting in full flow. Diagonal will divide the parallelogram in two congruent triangles. So this is the first theorem. Second theorem, the more basic things which I have discussed in the class, I'm not going through it, that parallel sides are opposite sides are parallel and equal, and opposite angles are equal and all these things, and two adjacent angles are to 180-degree. This we have already done in the class. So second is opposite sides are equal, we all know it. Theorem 3 tells that opposite angles of the parallelogram, so if this is a parallelogram, so opposite angles would be equal. So angle A would be equal to angle C. Suppose I name them A, B, C, D, and angle A would be equal to angle C, and angle B would be equal to angle D. Okay, Ritu has also joined. Good. So we have almost everyone except Shreya and Sanjana, perhaps. Okay, great. Now look at here. Now next one is the diagonals of the parallelogram bisect each other. So till now I have done theorems. First was that diagonal creates two congruent triangles, opposite sides equal and parallel, then opposite angles are equal, then we have diagonals bisect each other. Now understand, diagonals don't bisect each other at 90 degrees, so please don't have that in mind. So in parallelogram the angle is not 90-degree between diagonals, so diagonals bisect each other. This I have told you in the class also, bisect each other. Also, next theorem is, so I'll prove one theorem out of this. Next theorem is, in parallelogram bisector of any two consecutive angles intersect at right angle. So how do you prove it? This is a good question. So in parallelogram, these are just extension of what we have discussed till now, and we have discussed till now that diagonals create two congruent triangles, opposite sides are equal and parallel, opposite angles are equal, diagonals bisect each other, as simple as that. Now in parallelogram, bisectors of any two consecutive angles, so I am taking angle A, I am taking angle B, and this is bisector of angle A and B. Now try to understand, guys. If A is equal to C, so suppose this is C and this is D, and let me make it capital for you, and B is equal to D. So try to understand angle A plus B plus C plus D is equal to 360 degrees. Now A and C are equal, so I can write it 2A, and B and D are equal, so I can write it 2B. So try to understand, 2A plus 2B is equal to 360 degrees. So A plus B would be equal to 180 degrees. As simple as that. Now try to understand what happens. These are the bisectors of, suppose, AO. So I'm writing OA and OB. They are bisectors of what? Angle A and angle B. So what happens? I take half A from here. So half A plus half B, which is this angle, and plus this angle O, should be equal to 180 degree. Now you look at here, A plus B is equal to 180 here. So half A plus half B would be equal to 180 divided by 2, which is 90 degree. So half A plus half B is equal to 90 degree. So I'm writing 90 degree plus O, that is equal to 180 degree. So angle O will be equal to 180 minus 90, 90 degree. So what is the theorem? Theorem says that bisector of the any two consecutive angles, or I'll say adjacent angles, will meet each other at 90 degrees. So what this would be? This would be 90 degree, as this theorem suggests. Next theorem is, if a diagonal of parallelogram bisect one of the angles of parallelogram, it also bisects the second angle. Also prove that it is a rhombus. So this you can go through, this is not that difficult. Okay, next one. This is the last theorem of this theorem. I want to prove the angular bisector of the angular bisector of a parallelogram form a rectangle. So look at here, what I'm trying to do is that I'm drawing a parallelogram for you. This is A, this is B, this is C, this is D. Now these are the angular bisectors. So let me draw a line. So this is A. So suppose AP. Then suppose this is angular bisector here. Now suppose this is angular bisector here. And now suppose this is angular bisector here. Now guys, try to understand it. This question is very easy. We just proved that this angle P would be 90 degree. So what and this angle P would be 90 degree. And if this angle is 90 degree, this angle would also be 90 degree. So let me make a bigger diagram for you so that you can understand it properly. Suppose this is A, this is B, this is C, this is D. So this is the angular bisector AP. This is the angular bisector BR. This is the angular bisector of angle C. This is the angular bisector of angle D. So I'm putting it PQ. Sorry, this is S. So this is S. Now we have just proved that this angle, any two consecutive angular bisector or angular bisector of any two consecutive angle will meet each other at 90 degree. So angle P would be equal to 90 degree. We have just proved that. Similarly, angle R, which is at the point where angular bisector of angle B and D are meeting. So angle R would also be equal to 90 degree. As simple. Now, look at here. Now, what would be this angle? This angle will also be angle S is also 90 because consecutive angles A and B and their angular bisector is meeting at S. Now, if S is 90 degree, opposite angle to S would also be 90. And similarly, Q will be 90 degree. So, opposite angle to Q will also be 90 degree. So, opposite angle to Q and opposite to S, that is also 90 degree. So all the angles of PQRS are 90 degrees. Hence it can be proved that PQRS is a rectangle. That's simple. So now let me take a few questions for you guys and then I'll move ahead. So I'm not taking easier questions, I'm taking difficult questions only. Now I'm taking 2-3 questions from level 2 of R.D. Sharma book. So one question which I am taking is this. In a parallelogram, I'm just writing parallel for so that you can understand that. ABCD, the bisector of angle A also bisects BC at X. Prove that AD is equal to 2AB. So now guys, look at here. So suppose I have a parallelogram. So I have a parallelogram here and this is A, this is B, this is C, this is D. So bisector of A. So bisector of A would be something like this. And now bisector of A meets BC at X such that it bisects BC. It means that BX is equal to CX. It has been given. Also AX is angular bisector of angle A. So how can you prove it? So suppose this is angle 1 and this is angle 2. So angle 1 is equal to half A if it is an angular bisector. Now, angle A plus B is equal to 180 degree if it is a parallelogram. I'm writing here because it's a parallelogram. So angle B is equal to 180 degree minus angle A. Now in triangle ABX, angle 1 plus angle B plus angle 2 is equal to 180 degree. So try to understand. Angle 1 can be written as angle A by 2. I am writing angle 1 is equal to angle A by 2. Already it has been given here. So I am replacing this with angle A by 2. Angle B can be written as 180 degree minus angle A plus angle 2 is equal to 180 degree. Now guys, try to understand how to prove AD is equal to 2AB. What needs to be done? I have to prove that this side is 2 times of this side. Now how this can be proved? To prove it, I need to show that, try to understand. If I am able to show that, see what happened, opposite sides are equal. So if opposite sides are equal, if AD is 2 times AB, then BC will also be equal to 2 times AB. So I'm writing here, if I have to prove AD is 2 times AB, if I am able to prove BC is equal to 2 times AB. Are you understanding? Because AD and BC are equal in parallelogram. And now BC is getting divided into two equal halves, BX and CX. So try to understand, if I am able to prove that BX is equal to AB, then my work is done. So my objective over here is that what I need to do, I need to prove that angle 1 is equal to angle 2. If I am able to prove angle 1 is equal to angle 2, in that scenario what happens, I am able to prove that triangle ABX would be an isosceles triangle, and in an isosceles triangle what happens here is, in isosceles triangles what will happen is that sides opposite to equal angles would be equal. That is why till now I have been trying to find out relationship between angle 1 and angle 2. How can I find out relationship between angle 1 and angle 2? So I have taken the reference of triangle ABX. If I take a reference of triangle ABX, so what happens in that scenario, that angle 1 plus angle 2 plus angle B, which I have written here, is equal to 180 degree. Now angle 1 I know is A by 2. Angle A and B I know the relationship. So I can find out the value of angle B, which I am finding out here in terms of angle A. And that's how I will only have relationship between angle 1 and angle 2. So try to understand here. What I write is this 180 and 180 is 1. Now I have angle 2 and A by 2 minus angle A is minus angle A by 2. That is equal to 0. So angle 2 is equal to angle A by 2 and angle 1 is also equal to angle A by 2. So see here I have proved that angle 2 is equal to angle 1. And if angle 2 is equal to angle 1, then I am writing here, look at here, then I can write that AB is equal to BX. And if AB is equal to BX, which is also equal to CX, so BC is equal to, which is equal to BC by 2, which is also equal to which is also equal to AD by 2, as simple. So I have proved here that this side AB is half of AD, or AD is 2 times AB. So in this question, the question was all about proving that. Always remember, they could have, in this question, they could have easily given AD should, or BC should be equal to 2AB. But as soon as they could have given BC, your mind could have got that, prove that this BX and AB are equal because they have been divided into two parts. So you take it. So just to confuse you, they have given AD. But you should know that in a parallelogram, the opposite sides are equal. So as soon as you see AD, you should also look at the opposite side, which is BC. And now there has been a relationship. So you can prove that this BX is equal to AB, and you add BX plus CX. So it means that BC by 2 is equal to AB, or BC is equal to 2AB, or AD is equal to 2AB. So that's how you can solve the question. Next question, which I would take is, now let me erase, let me make some space for you guys so that you can understand that. Okay, now let me take next question of parallelogram. So next question is, ABCD is parallelogram. L and M are midpoints of AB and DC respectively. And a relationship has been given here, which is AL is equal to CM. We have to prove that LM and BD bisect each other. Now, how to solve this question? So suppose first I draw a parallelogram ABCD. In this parallelogram, what has been given? L is on AB. So let me mark L. And M is on DC. So let me mark M here. So it has been given that AL is equal to CM. Now, guys, that's not something kind of we need to know. We need to know that AB is equal to CD. In a parallelogram, opposite sides are parallel and equal. Now, if L and M are midpoints of each other, midpoints of AB and DC, then obviously half of AB would also be equal to half of DC. If AB is equal to DC, then half of it would also be equal to half of DC. And what is half of AB? Half of AB is L. And what is half of DC? That is equal to CM, which has been given here, which is a redundant data which doesn't need to be there. So most probably, if someone who knows this will not give you this relationship in the examination. Now, what I have to prove? I have to prove that LM and BD bisect each other. Suppose this point is O. Now, how do you prove it? How do you prove that LM and BD bisect each other? Or so to prove that LM and BD bisect each other, you have to prove that OB will be equal to OD and OM will be equal to OL. This is what you need to prove. So if this relationship is proved, these two relationships are proved, then your question would be done. Now, how do you prove it? So try to understand. See, OD and OM are part of triangle ODM. So I'm writing triangle ODM. So two sides are OD and OM are sides of it. Great. And I am writing OLB triangle. And look at here. OL and OB are part of it. Now I have two triangles and I have to prove that sides of this triangle is equal to sides of this triangle. This can only happen when I prove either similarity or congruency between the two triangles. Now in our syllabus only congruency is there, so your mind should directly go to the congruency, that I have to prove congruency. Wherever you have to prove that this side is equal to that side, at least once your mind should go to the word congruency, that is there some kind of congruency which can be proved. Now try to understand. See, this angle 1 is equal to this angle 2. Why? So angle 1 is equal to angle 2. Why? Because these two sides are parallel, so I am writing alternate angles. Now this angle DOM is equal to angle BOL, vertically opposite angles. So if I have proven that two angles of a triangle are equal, the third one has to be equal. So I have proven that all the angles are equal, as simple as that. So what you can do is, or to prove congruency, you can also say that now you know this relationship. So if you also know that BL is equal to DM, because they are half of, BL is half of AB and this is half of DC. I'm writing here, this is half of AB and this is half of DC, and if AB and DC are equal, these two have to be equal. So I have one side equal and the angles I have already proved that they are equal. So I have ASA congruency here. So angle side angle congruency here, or angle side angle. So this angle is equal to this angle is equal to this angle, and this side is, so angle side angle congruency here. So if I have proved congruency, so you can apply CPCT. What is CPCT? Corresponding part of congruent triangles are equal. So by CPCT, you can prove that OB is equal to OD and OM is equal to OL. Okay. So I hope you all understood it. If I am explaining something and you guys are unable to understand, please ask questions. Next question. Next question is, I'm taking, this is the last question from parallelogram which I'm taking next, and I'm taking because a construction is required, extra construction is required here. Yes, Shraddha, AS congruency is also possible. There are a lot of congruencies are possible because you can prove different sides, and because the other angle is also equal, so you can say AS congruency was also equal. So you are absolutely right about that. Okay, now try to understand. Now suppose this is parallelogram ABCD. Oh, no, they are not saying this is a parallelogram. They are just saying this is a quadrilateral. So they are saying in a quadrilateral. So I am writing there, if ABCD is a quadrilateral in which AB is parallel to CD and AD is equal to BC, prove angle A is equal to angle B. Now, in this question, try to understand, all of you. Nobody is saying that ABCD is a parallelogram. So I'll never make the figure, first of all, which looks like a parallelogram. So I am making a figure something like this. So I'm just ensuring that AB and CD are parallel to each other and AD is equal to BC. Now try to understand. In this question, I have to prove that angle A and angle B are equal. Now, how do you prove two angles are equal? Do we need to prove that? I mean, in this particular question, I don't think there is a need to think about congruency or something like else. Why? Because in a quadrilateral the angles would add up to 360 degrees. So somehow you have to find relationship between different angles. And how can we find that? So try to understand. It has been given that AD is equal to BC. Now what I do is that I draw a line parallel to AD here and I mark it E such that AB ED is a parallelogram. So in that scenario, A plus E is equal to 180 degree. Now try to understand. Now if ABED is a parallelogram, then AD would be equal to B. Sorry, once again, have I made the diagram correctly? Yes, I made the diagram correctly. One second, AD is equal to BD. Okay, so AD would be equal to BE. Okay, and now try to understand what needs to be done here. Now this angle and this angle is equal. Sorry, not equal. 180. I mean the relationship between them is angle A is equal, angle A plus angle E is equal to 180 degree. Shraddha, in this question, we are not discussing that, we are not saying that ABCD is a parallelogram. We are just saying that ABCD is a quadrilateral in which AB is parallel to CD. So I'm just saying this and this are parallel and these two are equal. Now what happens here is I can write the relationship AD is equal to BE. Now AD is also equal to BC. Hence, it has been given here. This is because of the parallelogram, and this is because this has been given here. So that's why I am writing here. So now I can write that BE is equal to BC. So this and this are equal. And what kind of angle they are making? So if BE and BC are equal, so it means that, let me take a triangle BEC. If BE is equal to BC, then angles opposite to BE, angle opposite to BE is this angle C is equal to BC, angle E. So angle C and angle E are equal. Now try to understand. So I can write this angle C, I can write this as, this is angle E is 180 degree minus angle A. Can I write it? And what is angle C? Guys, what would be angle C? Can anyone Dhruti, what are you asking? Tell me. Dhruti, what's your doubt? You can ask me. You can post it in the chat box. Okay, how is angle A plus E is 180 degree? 1 second. Oh, I'm sorry. Angle A plus B is equal to 180 degree. I'm sorry. Angle A is equal to angle E. I'm just writing here. Oh, I have corrected it, Dhruti. Angle A plus B is 180 degree and angle A is equal to angle E. So I have corrected it. Okay, so guys, try to understand. Now angle A and angle E are equal. I have proved that angle C and angle, I'm just removing it. I have proved that angle C and angle E are also equal. So if I can write it here, angle A and angle C are equal. Now look at here, if angle A and angle C are equal, these two lines are parallel and angle B is equal to angle C also. How angle B is equal to angle C? Because they are alternate angles. So there we can prove that angle A is equal to angle B. That is why I was getting confused, because I have written A plus E is equal to 180 degree. So when A is equal to E, C and E, I have proved that they are equal. How C and E are equal? Because I have made this diagram. So AD is equal to BE and it has been given that AD is equal to BC. So this is an isosceles triangle. In isosceles triangle, uh, angles opposite to equal sides would be equal. So angle C would be equal to angle E. Angle A and angle E are already equal. So angle ACE are equal. Now these two are parallel lines, AB and DC. So a parallel line cutting, a transversal cutting two parallel lines. So angle B and angle C on the other side would be equal. So it means that angle A would be equal to angle B. So that's how you have to solve these kind of questions. Now I'm taking different type of questions which are difficult in nature. So I'm moving ahead. Do you have any doubts? You can post it. If you have any doubt, you can post it in the chat box. Okay, nobody is posting anything, so I'm moving ahead then. Now, next topic in quadrilaterals is sufficient conditions for quadrilateral to be a parallelogram. Okay, Shreya is saying inequalities. Triangle, Shreya, is it triangular inequalities? Anchita is also saying inequalities. Is it triangular inequalities that you guys are talking about? Okay, so what I will do is, okay, what I'll do is remind me at 5:30 sometime. I'll start with triangular inequalities. In between, there was somebody who asked me this question of Euclid geometry. So there was a line given where it has been given like this. This was point A, this was point B, this was point C, and this was point D. So it was given that AC is equal to BD. You have to prove that AB is you have to prove that AB is equal to CD. So try to understand, AC can be written as AB plus BC and BD can be written as BC plus CD. Now both side BC is cancelled, so AB comes out to be equal to CD. This is what you need to do. So whosoever has done that, whosoever has asked, please note how the solution can be done to this question. Okay, I'm moving to other questions. So now what happens in your book, what has been given is that a converse of different theorems which we have given has been proved in your book. So I'll just remind you of the theorems that we have done, and then we will start taking up the questions. So I'll take 2-3 questions from parallelogram, then I'll move to rectangle, rhombus, square, and then a few questions from here and there, and then I'll move to triangular inequalities. Okay, Aditi, I'll just check. NPS RMR 9. Yes, Aditi, I solved your doubt. Question 6 I have already solved. AC can be written as AB plus BC, and BD can be written as BC plus CD. From both sides, BC will get cancelled out and you will get AB is equal to CD. So that's how you have to solve the question. That's it. Nothing extra is required. Okay, so now let me take different portion. So we till now we have covered that in a parallelogram opposite sides are equal. Now converse of the theorem can be said as a quadrilateral can only be parallelogram if its opposite side are equal. So this is the converse, and for everything you have been given proof. So I'm not doing those proof of the theorems. You just go through it. I don't think they'll ask also, but you just go through it. The second is a quadrilateral is a parallelogram if opposite angles are equal. Third one is a quadrilateral is a parallelogram if diagonals bisect each other. So it's converse of everything. So what I'll do is I'll take 2-3 questions from here and then I'll try to explain you guys. So the question is ABCD is a parallelogram. So I'll draw a parallelogram. So here I am. So I have a parallelogram like this. So this is A, this is B, this is C, this is D. And suppose this is AC and this is BD. And they are saying that X and Y are 2 points on the diagonals BD. So suppose this is point X and this is point Y, such that dx is equal to dy. So they are saying that dx is equal to by. I have to I have to prove that. I have to prove two, 3 things here. Prove that. Please make this diagram on your copy and write whatever I have said, so that when I change the page, you have the diagram and all the required information on your copy. So I hope you all are sitting with your copy and just not listening to me. So I have to prove that first one, AXCY is a parallelogram. So let me first prove it for you. So let me first construct AXCY. This is something like this. Now, if you have to prove that any particular quadrilateral is a parallelogram, what will you do? First thing first, we need to prove that opposite sides are parallel and equal. The second thing we need to prove is, or we can prove that xy, which is a diagonal, is making two congruent triangles. If it is making two congruent triangles, so I can easily prove that two sides are I mean, the first theorem that we discuss is that the diagonal of a parallelogram creates two congruent triangles on either side of the parallelogram. So you can do that also. So in proof one, what I do is that, suppose this is point O. Now, if ABCD is a parallelogram, I know that OB is equal to OD. How? Because parallelograms, diagonals of the parallelogram bisect each other. Now try to understand, if this is true, then OB minus BY would also be equal to OD minus DX. Why? Because BY and DX are equal. Already it has been given there. Now what is OB minus BY? Is it equal to OY? And is it equal to OX? So I have shown that in this particular quadrilateral AXCY, I have shown that these two OX and OY are equal. It means that this XY, which is a diagonal, is getting bisected by this point O. So this I have already shown. Now, here OA is already equal to OC because this is part of parallelogram ABCD. So I am showing that diagonals of this quadrilateral are getting bisected. I mean, they are bisecting each other. So the converse theorem is that if the diagonal of any particular quadrilateral bisect each other, what will happen? That particular quadrilateral would be a parallelogram. So I have shown here that the diagonals of AX, CY are bisecting each other if for any quadrilateral I find diagonals bisecting each other, then what will happen? Then we can write that this is a parallelogram. So this was the first proof. What is the second proof? Let me just remove it. The second proof is I have to prove that AX is equal to CY. Now, as soon as you prove that as soon as you prove that AXCY is a parallelogram, AX would be equal to CY. Next, I have to prove that AYB is congruent with CXD. Now, how can you prove that? Now, guys, try to understand what is AYB. So this and this are equal, this and this are equal, and this angle is equal to this angle. So you can prove that this is a congruent triangle. In parallel, what I'm trying to say is that AB is equal to DC and BY is equal to DX, and angle ABY is equal to angle XDC. So side angle side congruency can be proved. Now let me move to the third one. Now they are saying AXD. Again, the same thing they are asking, so I'm not getting into it. So this was one question which I thought which was important for you. Now let me move to another question which is also an NCRT question. So I'll solve two more questions from here, and then I'll move to rhombus and rectangle, and then perhaps I'll move to what you guys were demanding, which is inequality. If I'm not able to complete, I may extend the class by 15-20 minutes. Let's see what happens. So let me remove it. Now next question is, no, we have done this question, so I'm not taking this. Yes. Next, this question is very important. All of you, please focus. You have been given, so I'll write the question so that you have idea what we are trying to do. If triangle ABC and triangle DEF are such that AB, BC are respectively equal to and parallel to DE and EF, then show that one AB ED is a parallelogram. Now let me make a diagram for you. So what is happening? I have two triangles. So this is my one triangle A, B, C, and this is my second triangle D, E, F. Now I match it and just give me a moment. Suppose something like this. So this goes from here and this goes from here, and this is C. Now AB is equal to DE and BC is equal to EF. Now what happens guys is I have to prove that ABED. It means that which two sides? ABED. So look at here. AB and ED are equal. It has been given. And BC and EF, it has been given. So what more do I need to prove that ABED is a parallelogram? So let me write, first of all, AB is equal to DE and AB is also parallel to DE. Also try to understand ABD. Now look at here. Now only A, B, ED are involved. This BC and DF is not involved here, guys. So if I am able to prove, always remember this question is not difficult. This question was just about remembering the converse theorem. And what was the converse theorem? That for any quadrilateral, if opposite sides are parallel and equal, it has to be a parallelogram. So I am proving that AB, which is part of this side, and this particular side, which is opposite to it, are parallel and equal. Already it has been given to you that they are parallel and equal. So you just need to write that they have been given, and you just need to write the converse theorem that as for this particular quadrilateral, opposite sides are parallel and equal. Hence this quadrilateral ABED would be a parallelogram, as simple as that. Now another quadrilateral has been given, which has been given BCEF. So BCEF, again here also what you need to do, BC is equal to EF, BC is parallel to EF. So you just write that two sides are equal and parallel. You have been proven this. So just because two triangles have been given in this question, don't get discouraged. Just make diagram. I know this diagram is not proper. So let me make a proper diagram. Like this. Now this looks like a proper diagram. So this is A, this is B, this is C, and this is D, this is E, this is F. So AB, ED I have already proved, which is the front side. BCEF, which is the base of it, I have already proved it. Now if somebody is asking you to prove AC is equal to DF, you should write that. How do you prove AC is equal to DF? This will also be AC DF will also be a parallelogram. So if AC DF is also a parallelogram, then what happens? AC becomes equal to DF. So this is how you have to solve these kind of questions. I hope you understood this question at least. Now let me move to properties of, and this is not very, properties of rectangle, rhombus, and square. So for all of them, for each one of them, the angles, no, have I included rhombus? Removing rhombus for rectangle and square. I'm sorry, I'll just correct myself. For rectangle and square angle, each angle would be 90°. Now for both rectangle and square, opposite sides would be parallel and equal. So sides are equal. In rectangle, opposite sides are parallel and equal. In rectangle, the diagonals will bisect each other. I'm not saying they are perpendicular bisector. I'm just saying they'll bisect each other. In square, diagonals will do bisect each other, but they'll also be perpendicular bisector. In a rectangle and square, the length of the diagonals would be equal. I'm not talking about rhombus till now. So what I have done, I have till now said that in rectangle, opposite sides parallel and equal, diagonals are equal, they bisect each other, they are not perpendicular bisector, all the angles are 90°. Till now I have said that. Square, I'm saying all sides are equal, diagonals are equal, they are perpendicular bisectors, all the angles are 90°. Now let me move to rhombus. So in rhombus, opposite sides are parallel. One second, guys. Okay. One most important parameter of rectangle or property of rectangle is diagonals bisect each other at 90°. Now each side, I mean, this is I mean, from here only, from rhombus only, we construct square by making all sides equal. So we need to understand that in rhombus, all four sides would be equal. Opposite sides are parallel. This is 90 degree. Now what is the difference between rhombus and square? This angle is not 90 degree in rhombus. So opposite sides, opposite angles are equal. Rhombus, all sides equal. Opposite angles equal. Then you have diagonals perpendicular bisector. So these are the few properties of, yes, Shraddha, rhombus. That's what I have been saying, that in rhombus we have diagonals at 90 degree. I've told 2 times that in rectangle we don't, the diagonal do not, in rectangle the diagonals are just bisector. They are not perpendicular. I'm not saying that this angle is 90 degree. So let me now solve a few questions from here, and I'll solve only difficult questions, as you know. So let me take a question. Which question I should take? So, okay, let me take a theorem only. Let me check how many of you can solve it. Okay. Please remind me, guys, at nearly 5:20 that I have to go to triangular inequalities. So anyone, please put it in the chat box. I'll move to triangular inequalities. I'll try to solve difficult questions from there. Do you guys have any problem in Heron's formula? Anyone? You can just post it. Heron's formula. Okay. Now let me take it. The question, if diagonals of a parallelogram are equal and intersect at right angle, then the parallelogram is a square. So what I am saying, I'll just make a square first of all, and I'll say this is ABCD. The information that has been given in the question is, people are saying they don't have problem. Shraddha is saying she doesn't have problem in Heron's formula. All others, are you guys listening to me? At least write yes or no. If the diagonals of a parallelogram are equal and intersect, so diagonals of the parallelogram are equal. So AC is equal to DB, that has been given to me. Now what more has been given to me? Suppose this point is O. What more has been given to me? That they intersect each other at right angles. So AOB is equal to 90 degree. That is also equal to BOC, and that is also equal to DOC, and that is also equal to AOD. Okay, great. Nobody has problem in Heron's formula, so I'll not teach Heron's formula then. Great. Now, how do you prove that this is a square? What we need to do? So, we need to prove two things. First, we need to prove that this side and this side are equal. Why I am proving AD and AB is equal, or I'll prove AB and BC is equal? Because it has already been given that it is a parallelogram. So in parallelogram, I'll write what has been given to me. AB is equal to DC, it has been given to me, and AD is equal to BC, it has been given to me. If we prove AB is equal to AD or BC, then all four sides would be equal. And then I have to prove that this angle and this angle is adjacent angles are 90 degree. Why? Because A and C are already equal because it is a parallelogram, and B and D is already equal because that's a parallelogram. So if I prove that A and B or C and D, any two all adjacent angles are 90°, I'll be able to prove it. So now try to understand, guys, how to. First thing first, if I have to prove that sides are equal, what should go in my mind? The first thing should be I have to prove congruency somehow. So let me take triangle AOB and triangle AOD. In triangle AOB, I am taking side AO. In triangle AOD, I am taking side OD and I am writing it equal. How I am writing it equal? Because I have been given that diagonals are equal. If diagonals are equal, half of the diagonals, AO is equal to half of AB and OD is equal to half of BC and AB is equal to BC that has been given to me. And that is why I have written AO is equal to OD. Now guys, try to understand. Angle, now see, this is 90° and this is 90°. So what I can prove? I can write, not prove, I can write that AOB is equal to angle AOD, which I have already written there. This is 90° perpendicular, it has been given to me. What else? So I have proved, I have written that this side and this side is equal. AO is equal to, no, one second. I can also write that AO is equal to AO because AO is common to both of them. So I am proving the congruency, Sas congruency I am proving here. So by Sas congruency, what I'm trying to prove that these two triangles are congruent, as simple as that. And if these two triangles are congruent, then by CPCT, sides opposite to this 90° angle would be equal. So I can prove that AB is equal to, sorry, I'll write AB is equal to AD. If I prove that AB is equal to AD, automatically I prove that all four sides are equal. Now, how do I prove that this is 90°? So, now look at here. Guys, now see, this side and this side is equal. Now let me make a new diagram for you on the next page. So this is like this. This is ABCD we have written, and this is the diagonal and this is the diagonal. Now try to understand, this is 90 and this is 90 and this is 90. Now we have proved that this and this are equal and this are equal. How we have proved? Just we proved that these two triangles are or we can say that half of the diagonals would be equal because diagonals are equal. Now let's try to understand. If I mark it O, so triangle AOD, don't you think it would be an isosceles triangle? And if it is an isosceles triangle, so suppose this is theta and this is theta, so theta plus theta 2 theta and this is 90°, so that is equal to 180°. So theta comes out to be 45°, and here also this and this are equal and this is 90°. So this theta 1 and this is theta 1. So try to understand, you can write that theta 1 is also 45°. So you what is angle A? Angle A is equal to theta plus theta 1, which is equal to 45 plus 45, which is 90°, as simple. So anyhow you can prove that that would be 90°. Or what you can prove, so you take triangle ABD, you take this triangle. In triangle ABD, this and this is equal. So this and this is equal. So this is how much? This is 45 degree. This is 45 degree. So how much this complete angle would be? 90 degree. If I take, I am making here, perhaps you are not understanding, I am taking only one diagonal. So I have just proved that AD is equal to AB. So AD AB equal. So this is an isosceles triangle. What happens in that scenario? In that scenario, you can prove that, or you can prove from here, you can prove that ABD is congruent with BAC. So in that, so any way you can prove this. All the congruences can be proved and angle can be found out. I will like this method, so utilize this method. Or you can say that this and this, so this is theta1 and this is theta1. Similarly, you can say this is theta and the other one is theta. So theta1, every angle can be found out and you can find out value of theta and theta1. So anyway, you can find out this answer. Now let me take one good question, which is an NCERT question. So how many of you are prepared for Math 2 examination properly? I know none of you will reply for this question. None of you will reply for this question. So it has been told that ABCD is a rectangle in which, so I have ABCD, which is a rectangle. I'm solving a question in which ABCD is a rectangle, in which diagonal AC bisects A and C both. So AC, Shraddha is saying okay, okay, sir. What do you mean by okay, okay preparation? AC bisects angle A and angle C. So you have to show that or prove that. What is ABCD? ABCD is a rectangle. None of you should get less than 85%. Anchita is saying it's going on. Preparation always goes on. 85% is minimum for all of you. That's the target. So out of 30, it has to be more than 25. Or if it is out of 50, it has to be more than 42. So calculate how much you need to do. So what you have to prove? We have to prove that. Sanjana is asking how many marks it is for. I don't know. How many marks your examination is for? So you have to show that ABCD is a square. Okay. Now look at here. So how do you prove that ABCD is a square? What is the property of a square? We have to prove that if it is a rectangle, so let me write AB is equal to CD and AD is equal to BC. Why? Because of rectangle. All angles are 90 degrees. So here I don't need to prove angles. What I need to prove, I just need to prove that AD is equal to AB. If I prove, oh, it's 50 marks. Great. So your target is, forget about this question. Target is minimum 42 marks. This is minimum that you have to achieve. And maximum target is 50. So I'm just saying target is minimum 85%. because last time many of you did not get 85%. So this time it has to be 85%. Now if I prove AB is equal to AD, then in that case I'll be able to prove that ABCD is a rectangle. Now how do I prove that AB is equal to AD? Now it's pretty simple that I have to go to some kind of congruency or something like that. Now guys, try to understand what has been given to me. It has been given to me that angle A, or you can write that if this is angle 1 and this is angle 2, so anyway angle 1 is equal to angle 2. Now let me draw a diagonal from here also, and let me write down angle 1 is equal to angle 2 I have written. Now what is the another angle? Now this angle, which I am assuming to be angle 3, would be equal to angle 4 here. So angle 3 is equal to angle 4 here. Now try to understand guys. Angle 1 plus, so what can be done is that, one second, what I have to prove? I have to prove that so look at here. Can I somehow prove that this angle and this angle is equal? Because what happens in this scenario, if I prove that it is an isosceles triangle also, I in if it is not a congruency question, yes, AC is common, Shraddha. I'm just proving. I'm not trying to prove any congruency here. I'm just trying to prove if are the angles equal. Like if I can prove angle 3 is equal to angle 2, somehow I'll be able to prove, and that should be the case. See, angle 3 is equal to angle 2. Why angle 3 is equal to angle 2? Because angle 3 is equal to A by 2. Angle 2 is equal to C by 2, and angle A is has been given equal. So angle 3 is equal to angle 2. And what does that do? That tells me that triangle ACD is isosceles. As simple. So if it is isosceles, then sides opposite to equal angles would be equal. So what is the side opposite to angle 3? That is DC. DC is also equal to AB, and that is equal to AD, and AD is also equal to BC. So I have proven that all sides are equal. Angles are already 90-degree. That can only happen in case of square. So you prove that in this particular case it is square. Now let me solve one more question from here, and then I'll move to triangular inequality. And at last I'll ask you guys whether you have any doubt. So try to understand. This question is that this, I made it a bit bigger. So I have A, B, C, D, and what does it look like? Yes, Sanjana, I'm just going to, after this question, um, Shraddha, you don't need to prove that 90 degree in rectangle. If it has been given to you that it is rectangle, it has to be, I mean, angles has to be 90 degree. So if somebody is saying that it's a parallelogram, every time I will not go and prove that opposite sides are equal and parallel and triangles would, diagonals would bisect each other. If it has been given the theorems of that particular quadrilateral, I'll take as it is and use it in my question. So rectangle, if it has been given to me, I will assume that this is 90 degree. So it looks like trapezium, so it is a trapezium. Now what is in trapezium? AB would be parallel to DC. So AB is parallel to DC. Now AD is equal to BC. It has been given to me. And I have to show that angle A is equal to angle B. Best way to show that this is the same question. We just did this question in another form. Make it a parallelogram. I'll draw E here, and what I'll do, this AD, if it is a parallelogram, I'll make E such that ADCE is a parallelogram, and AD is equal to C. AD is also equal to BC. It has been given to me. So, and D is equal to E. So this angle and this angle would be equal. So I can prove that this angle and this angle is equal, or this angle is this angle, and this angle is equal. So this kind of question we have already done. Now let me move to triangular inequalities, which is in demand today. So guys, give me just 1 minute. I'll drink water and start. So do you want me to go from very basic, I mean theorems also, though there are only two theorems, three theorems. How many of them? Three, four theorems. Please reply quickly. Do you want me to do theorems or only questions? I'm waiting for your answer. Okay, Sanjana is saying theorems also. Great. I'll do theorems also for you. So I'm starting in 1 minute. Just give me one minute. I'll start in 1 minute. Yes, I'll solve problems and theorems both. There are only four theorems. You can open the book. If you have R.D. Sharma, R.S. Agarwal, anyone, you can open the book. There would be problem. I'm using R.D. Sharma only. So if it is in front of you, that would be beneficial. So I'll explain most of the questions. And then, okay, so what is the first theorem? First theorem is if two sides of a triangle are unequal, longer side has greater angle opposite to it. Theorem 1. Longer side has greater angle opposite to it. And this is very easy proof. How do I prove it? Just look at here. So try to understand, this is my triangle, and triangle is ABC. I am saying that two sides are unequal. So I am saying that AC is greater than AB. Assumption this is. So that I can confine myself to this particular statement. Now try to understand. I have to prove that larger side has greater angle opposite to it. So what is the angle opposite to AC? Angle B, and that should be greater than angle C. This is what I have to prove. Now how do I prove it? Simple construction. If AC is bigger than AB, then a portion of AC would be equal to AB. Again, I am making this statement. If AC is greater than AB, then a portion of AC would be equal to AB. So I am making this line point D on AC. So construct BD such that AB is equal to AD. Now try to understand, if this is angle 1 and this is angle 2. So how many of you think that angle 2 would be greater than angle C? Or let me write it ACB. And why I say this? Because angle 2 is exterior angle in exterior angle in triangle BCD. Now, any exterior angle would be equal to summation of two other interior angles. I am only taking one interior angle C. So I am writing here angle 2 is equal to angle DBC plus angle ACB. So definitely if I delete this DBC, angle 2 would be greater than ACB. Now try to understand, if according to this construction where I am saying AB is equal to AD, so then triangle ABD would be isosceles. If triangle ABD is isosceles, then angle 1 would be equal to angle 2, because in isosceles triangle, I have been using this theorem in today's class for longer time. So in isosceles triangle, angle opposite to equal sides would be equal. So it also means that angle 1 is equal to angle ACB. Now look at here, this angle 1 is only part of this angle B. So angle 1 plus this angle 3 is equal to angle B. So angle 1 plus angle 3 is equal to B. So if 1 only is greater than this C, so 1 plus 3 would obviously be greater than this C. So that's why I am saying that angle B would be greater than, let me write here, angle B would be greater than angle C. So in this case, what I did, I'll revise it for you. What I did was, I assumed that AC is greater than AB. If AC is greater than AB, in that particular scenario, what happens is, I construct a line BD which is on line AC, and this BD is constructed. The objective of constructing this line BD, that I can make an isosceles triangle, and AB and AD I am making equal, and that is isosceles triangle. So I am putting angle 1 is equal to angle 2. I know that angle 2 would be greater than this angle, because angle 2 is equal to summation of both these angles and would be greater than any of angle 3, and suppose this is angle 4 or whatever it is. Now if angle 1 is greater than 4, angle 1 plus 3, which is complete part of B, will obviously be greater than 4. So that's why angle B would be greater than angle C. Okay, now let me move to another theorem, theorem 2. And what is theorem 2? So theorem 2 tells that it is converse, that in a triangle, theorem 2, in a triangle, the greater angle has longer side opposite to it. Now always remember, in converse kind of theorem, I'll utilize the first theorem. So in this theorem, which theorem I'll utilize? I'll utilize the theorem that I just proved, that the longer side has greater angle opposite to it. Now I have to prove that greater angle has longer side opposite to it. So try to understand this theorem. Proof of this theorem is very easy. So I have a triangle ABC where it has been given that AC is greater than AB. So I have to prove that AC is greater than AB, and I have been given that B is greater than C. So there are three scenarios that AC would be equal to AB. If AC is equal to AB, B and C both would be equal. If AC is equal to AB, so isosceles triangle, B and C equal, which goes opposite to what I have assumed here. Is it okay? If AC is less than AB, so what happens in that scenario? So as soon as I write AC is less than AB, so angle opposite to AC would be lesser than angle opposite to AB. So here B would be lesser than C. I already know that angle B is greater than C. So there is only one scenario left out, which is AC is greater than AB. So what in this particular proof, what I am trying to do is that I am trying to say that AC is not equal to AB, because if AC is equal to AB, both B and angle B and C would be equal, which is opposite to my condition given that B is greater than C. I am saying that if AC is lesser than AB, so angle B would be lesser than C by first theorem, which I just proved. So this is also opposite to what I have assumed earlier. So there is only one case left out, that AC is greater than AB. So this is how you prove this. Now let me move to third theorem. So third theorem is theorem 3. Sum of two sides, any two sides of a triangle is greater than third side. So suppose this is triangle ABC. Just look at the proof. This proof is a bit tedious because I have to do the construction. So I have to prove that AB plus AC greater than BC. So this plus this is greater than this. How do I do it? So I draw a line from here, and suppose this is point D, such that this construction I am writing here, AB is I'm writing here, I am making this AD equal to AC. So AC is equal to AD. So try to understand. Let me assume angles. This is angle 1, this is angle 2, this is angle 3, this is angle 4, this is angle, this internal angle 5, and this is angle 6. Let me assume angles like this. So if I am saying that AC is equal to AD, in that particular scenario, what happens is that what happens is that what happens is that this becomes an isosceles triangle. So angle opposite to equal sides would be equal. So AC and AD are equal. So opposite to AD angle 5 is coming, and opposite to AC angle 4 is coming. So look at here, angle 5 is equal to angle 4. Now, okay, guys, let me just make a bigger diagram for you so that you can understand it properly. And let me remove it also. So a little bit of bigger diagram here will help our cause. So this is A, this is B, this is C, this is D. I've already written here AC is equal to AD. Now this is angle, suppose this is angle 1, this is 2, this is 3, this is 4, this is 5. I've changed the angles, 6. So in triangle ADC, AC is equal to AD. Now if AC is equal to AD, in that particular case, angle opposite to AC, angle 5 is there. Opposite to AD, angle 6 is there. So angle 5 is equal to angle 6. Now try to understand. Now suppose I take this angle. 1 second. Look at here, guys. Now suppose I take this angle. So what is this angle? Angle 3. And I take this angle, angle 6. Angle 3 plus 6 would be greater than angle 5. How do you say this? This is the only part of the proof where students struggle to understand properly, and they leave it here. How do you prove it? That angle 3 plus angle 6 is greater than this angle. Anyone can tell me? Can anyone tell me? Write something. So what happens is, look at this angle 5. What I'm trying to do is that I'm telling that angle 3 plus 6 is greater than angle 6. As simple. This is just saying that angle 3 plus 6 is greater than angle 6. And why am I doing it? Let me discuss the concept first. Leave the question altogether. I have to bring some kind of inequality. How do I bring inequality? So to bring inequality, what I do in this particular question is that I am just saying that this angle plus this angle is greater than this angle. So then why I am going here? I am going here because I don't need angle 8 side AD here. What I need side AC here, and that is why I am going to angle 5 here. As simple as that. So from here I can say that angle 3 plus 6, which is this complete angle C. So let me write it. I will say that angle in BCD, which is this complete angle 6, would be greater than angle BDC. I mean 3 plus 6, which is this complete angle BCD, will be greater than this complete angle BDC. So it means that it is just telling me that what is the side opposite to BCD? So what is the side opposite to this particular angle? So side opposite to this particular angle is this complete BD, and BD is greater than what? BD is greater than side opposite to BDC. Now guys, understand, opposite to this there are two sides. AC is also there and BC is also there. Now you have to look at the triangle, which triangle I am using. I am not using triangle ADC that you will use AC. I am using the complete triangle BDC, so I'll use BC. So I will write BD is greater than BC. Now I am writing here what is BD? BD is AB plus AD, and that is greater than BC. I know AD is equal to AC, so I can write that AB plus AC is greater than BC. So this is like this. How many of you understood it? Please let me know how many of you understood it. How many of you are there? Few of you have already left it. Those who are there, how many of you understood it? Should I need to explain once more? Okay, Shraddha understood. What about you, Sanjana? Did you understand it? Okay, Ritu is saying understood. Oh, Anchita is saying these guys didn't understand. So I'll explain once more. Anchita, you try to understand. I'm constructing AD which is equal to AC. So I'm going to first this triangle ADC, and I'm saying that angle 5 is equal to angle 6. Now why I'm saying angle 5 is equal to angle 6, because I have constructed AD equal to AC. So in the isosceles triangle, what happens? So angles opposite to equal sides would be equal. That is why I am saying that angle 5 is equal to angle 6. Now try to understand this particular angle 3 plus 6 would be greater than angle 6. Now angle 6 is equal to angle 5, so I am taking angle 5. What is 3 plus 6? So angle BCD is equal to angle BDC. So what is 3 plus 6? 3 plus 6 is this complete angle BCD. So I have written BCD, and angle 5 is angle BDC. So I have taken angle BDC. So opposite to BCD, this complete side BD is coming. So BD would be greater than, by theorem 1, greater angles have larger side opposite to it. So greater angle is BCD, opposite to it larger side would be there. So I am writing BD greater than, what is opposite to BDC? Opposite to BDC, BC would be there. So this is BC. So BD is how much? BD is AB plus AD. So I am writing BD as AB plus AD, and that is greater than BC. Now I know from here that AC is equal to AD. So AB plus AC is greater than BC. So this is how you have to do it. Now let me move to a few questions. So I'll take difficult questions from here so that you can solve those questions in your exam. Okay. I'm solving this question. If you are with your RD Sharma book, I'm solving page 12.76. Question 18 on that page. So it is saying that PQR is a triangle. I'll solve some 4 or 5 questions from here. PQR is a triangle and S is any point in its interior. So S is any point in its interior. So I'm assuming S to be here. Now it has been telling that, prove that SQ plus SR is greater than PQ, sorry, 1 second, is lesser than, that's why I got confused, is lesser than PQ plus PR. Now, how do we do it? So, in this particular question, a construction is required. So, let me extend this SQ. You can do it on this side also. So, extend it to this side and suppose this is T. So, what happens? I take triangle PQT. And in triangle PQT, PQ plus PT would be greater than QT. And what is this QT? Why I'm keeping QT on this side? Why I'm not keeping QT on other side? I'm not putting QT on other side because for SQ, I want to show SQ lesser than something. So that is why SQ is part of QT. So I'm keeping it on the lesser side. So PQ, 1 second guys, I did something, I just closed it. 1 second, it got closed. 1 minute. Okay, so look at here, I will write PQ plus PT is greater than SQ plus ST because QT is equal to, I'm writing here, SQ plus ST. What else I'll write? Now I'll go to this triangle because I want SR, I'll go to this triangle. So what I'll write in triangle, in triangle SRT, ST, I want to cancel ST. So here ST is on the lower side. Here I'll put ST on the other side. So ST plus TR, and see PT is there here and TR I am keeping here. So if I'll add PT plus TR, I'll get PR. So ST plus TR is greater than SR. Now this is my equation 1. This is my equation 2. I'll add both the equations. So add equation 1 and 2. So I'll write PQ plus PT plus ST plus TR is greater than SQ plus ST plus SR. Now ST is gone. PT plus TR is PR. So PQ, PT plus TR is PR. So PR is greater than SQ plus SR. This is how you prove it. Did you all understand it? Now let me move to another question. So I'm taking difficult questions only. I'm not taking easier questions. You can go through it. Questions are easy before. So first 6-7 questions and you'll get this kind of questions only. So nothing more than that. Let me move to this question on page 12.75. I'll solve 2-3 more questions. So if it is going beyond 6 o'clock, please be signed into the session. Question is, show that sum of 3 altitudes. And remember this, sometimes this is used directly, like if you'll go to sum of 3 altitudes of triangle is less than sum of its 3 sides. So I'm making a triangle here, and this is my triangle ABC. Now this is AD, this is one altitude, this is BE, this is second altitude, and this is CF, which is third. So I have to show that AB plus BC plus CA is greater than AD plus BE plus CF. Now how do you do it? Now try to understand. So there was one theorem which I didn't prove, and that theorem which would be utilized here. And what was that theorem? So I'm discussing that theorem and then I'll remove it. So suppose there is any point and this is line, and this line is suppose xy. So, and this is point O. So what is the minimum distance of point O from xy? So minimum distance of any point from any particular line would be a perpendicular distance drawn from here. So try to understand if this is OM and this is OX and OY. So minimum distance would be OM, not OX and OY. Why? How to prove it? So go to any triangle OMY. Now this is 90 degrees. So in this triangle, all these angles would be lesser than 90 degree. Hence, greater angle will have larger side opposite to it. So this is the greater angle 90 degree, or both the angles are lesser than 90 degrees. So OY would be greater than OM. Similarly, you can prove that this OX is also greater than OM. Or even if you don't know it, by Pythagoras theorem, you can say that hypotenuse is greater than the base also and perpendicular also. So look at here, if this is 90 degree, it can be easily said that AB is greater than AD. And it can also be said that AC is greater than AD. Can I say that? Obviously, I can say that, because if you look at this, if I go to in triangle ADB, AB is hypotenuse. So hypotenuse would be greater than the perpendicular. AB, what is AB? AB is hypotenuse. And AD is what? Perpendicular. So hypotenuse will always be greater than perpendicular, because I am anywhere not including base here. AD is what? Perpendicular. So what I write from here, I add both of this. So I am writing here AB plus AC. Just add it. Should be greater than equal to 2AD. Now, let me just remove this. Similarly, I can write that. Similarly, I can write that in this, BC would be greater than CF and AC would be greater than CF. Why? Because in triangle BCF and ACF, BC and AC are hypotenuse. So let me write this again. So AC plus BC is greater than 2CF. Similarly, I can write in this triangle that BC is also greater than BE and AB is also greater than BE. So I write that AB plus BC is greater than 2BE. Now I have three equations. This is my equation 1, this is my equation 2, and this is my equation 3. If I add all these three equations, so AB is coming how many times? 2 times here. AC is coming how many times? 2 times here. BC is coming how many times? 2 times here. So it becomes 2AB plus BC plus CA is greater than 2 times AD plus BE plus CF, and you have already proved the inequality. So 2 cancelled, your inequality is proved. So this is how simple it is. Now let me move to another question which is on page 2.76 only. So I'll solve 2-3 more questions and then I'll wrap up the session. Okay, let's solve another question. So it has been given to, we prove that first one, sorry, page 12.76 again. Question 17. So it has been given to that show that the difference of any two sides of triangle is less than the third side. So suppose this is triangle ABC and I have to show that AC minus AB is lesser than BC. So sorry, this is AB is lesser than BC. So what I do? So try to understand. From here extend a line D here. And what do you do with this line? So there are four angles getting formed. Suppose this is angle 4. On this side, this is angle 1. This is suppose angle 2. And this is suppose angle 3. So how many of you think that and obviously I forgot to write AB is equal to AD because I want to create this kind of question we have already done. That when we did this kind of question to prove theorem, which theorem? The first theorem, that greater angle has larger side has greater angle opposite to it. Now guys, try to understand, this angle 3 would be greater than angle 1. Try to understand. Let me make a bigger triangle for you. From here I'm drawing a line AD, and this is my angle 1 and this is my angle 3. I'm saying this angle 3 is greater than 1. Why? Because exterior angle 3 would be greater than 1 of the interior angle. And I'm also saying that this angle 2, sorry, this angle 2 and this is angle 4, this angle 2 would be greater than angle 4. Why? Because exterior angle 2 would be greater than any other exterior angle 4. Now try to understand. I have constructed AB is equal to AD. AB is equal to AD. So if AB is equal to AD, angle 1 would be equal to angle 2. So try to understand. I can write from there that if angle 3 is greater than angle 1, if angle 3 is greater than angle 1 Angle 3 would also be greater than angle 2 because 1 and 2 are equal. Now, if angle 3 is greater than angle 2, angle 3 will automatically become greater than angle 4. So if angle 3 is greater than angle 4, in that scenario, what happens? What is the side opposite to angle 3? Side opposite to angle 3 is BC. And what is the side opposite to angle 4? That is CD. Now try to understand BC and what is CD? CD can be written as AC minus AD. CD is equal to AC minus AD. Now this AD is equal to AB, so I can write AC minus AB. So AC minus AB. If somebody is asking you that you don't have to prove AC minus AB, you have to prove AB minus AC. So where you will do the construction, try to understand whichever side is coming here, the tip of the construction should be here, and whichever side is getting whichever side is negative, whichever side is getting subtracted, the initial point of the construction line should be there. So see, AB was getting subtracted, so initial point is starting from B and it is going to AC. So this is how we have to do this. So now let me move to a question on page 12.77. And then one more question and then I'll wrap up the class. So this is second last question of the class. After that, if you will have any doubt in one particular question, I can solve. Otherwise, now Shraddha, if you are there, most of the questions of that sheet would be solved. You go there, only this kind of questions are there. So most of the questions of the sheet I have given should be solved with the help of the concepts that we have discussed now. Now look at here, we have done this kind of questions, this type of question in the class also. This is any particular line segment LR on which I have 3 points. So this is point Q, this is point P, and this is point S. Now here is a point A. So I am drawing a triangle A Q and this is going to R. So this is triangle AQR. In triangle AQR, AP is perpendicular. So AP is perpendicular to LR. And it has been given to me that this is given. What more has been given to me? That PR is greater than PQ. This has been given to me. It means that this is greater than this. What I have to prove is show AR is greater than AQ. Now, how do you prove it? So look at here. I will draw any particular line AS. Now, why am I drawing any particular line AS? Because it has been given to me that PR is greater than PQ. I am drawing any line S. Try to understand in this kind of question, time and again what I am trying to do is wherever any particular side is greater than other side, on the greater side I am taking a point and making portion of that greater side equal to the smaller side. So here I have this, I'm drawing this point PS such that PS is equal to PQ. Now I can show that, look at here, this is 90 degree. So I'm not going into details of this. You can show that this is also 90 degrees. So this angles are, now this is equal to this and AP is common. So you can show that this is SAS congruency in triangle APQ and triangle APS. Again, I'll do this. PQ is equal to PS, AP is equal to AP, and angles are 90 degree. Both angle P, both side is equal. So SAS congruency. If SAS congruency is there, what do I prove? I prove that AQ is equal to AS. That's what I do. And if AQ is equal to AS, then this angle, suppose I am assuming this angle to be 1 and this angle to be 2. So I can prove that angle 1 is equal to angle 2. And if I prove that angle 1 is equal to 2, suppose this is angle 3. So angle 2 would be greater than angle 3. Why? Because exterior angle would be greater than one of the interior angles. As simple as that. So if angle 2 is greater than angle 3, then angle 1 is also greater than angle 3. Now if angle 1 is greater than angle 3, so larger side is always opposite to greater angle. So opposite to angle A is what? 1 is what? AR. Opposite to angle 3 is what? AQ. I can write AR is greater than AQ. So this is the case. Now let me go to the last question. And last question I am taking from page 12.78 only, question 21, which tells that in quadrilateral PQRS, and suppose these are the diagonals and this is point O, I have to prove that PQ plus QR plus SR plus SP is greater than PR plus QS. And how do we do it? So guys, try to understand. I take this triangle. I take triangle PQR. So PQ plus QR will be greater than PR. Then I take this triangle in triangle SQR. QR plus RS is greater than SQ. Then I've taken this. Then I take other two triangles. So I'm not moving this. There are four triangles. One triangle would be this, one triangle would be this on this side, and then on this side. So four triangles would be created due to 2. You just keep on doing this, add all four of them. This would be 2 times this would be 2 times this. 2 will be get cancelled from here. The next thing that I have to prove here is, so I have taken this triangle. Now I can take this triangle. Which triangle? I can take these smaller triangles 1, 2, 3, 4. So if you take smaller triangles 1, 2, 3, 4, PQ would be lesser than OP plus OQ. Similarly, QR would be lesser than OR plus OQ. Similarly, SR would be lesser than OS plus OR. And similarly, PS would be lesser than OS plus OP. So if you add 4 of them, this would be summation of side of quadrilateral. This would be 2OP plus 2OR plus 2OQ plus 2OS. And what is this? Try to understand. OP plus OR is equal to PR. So I get how much? I get 2 PR here, and from here I get 2 QS. So this would be 2 times PR plus QS, and this would be greater than this. So this is what we needed to prove. So guys, I'm wrapping up the session now. We have done enough practice from quadrilaterals and from triangular inequalities. These are the two important topics which you guys told me to revise. Last class you guys told me to revise quadrilaterals, so that's why it was there in my mind and I revised quadrilaterals. Triangular inequality, I did it because though we have already done these things in the class, but this is an important topic and a lot of people get confused. So it's good that we have revised these things. Wish you all the best for your coming examination. I shall be available on tomorrow after 4 o'clock. I shall be available for you guys. So not 4 o'clock. Let's make it 5 o'clock. After 5 o'clock, I don't have anything as such. So whatever your doubt is there, you can post it. You can get in touch with me because I know 29th is your examination, and on Saturdays and Sundays also I shall be available for you guys. I'm always available, but these are the days when I have not much work to be done, and I shall be available to clarify your doubts. So please feel free to get in touch with me, and if you have any doubt, get it clarified as quickly as possible. What I want from you guys is that no doubt should be remaining once, I mean, before after I mean before you go for your examination. So for that, one thing is important, that you get in touch wherever you are getting the doubt. If you have any doubt now, you can ask me. Otherwise, we'll wrap up the question. Thank you so much for attending the session, and wish you all the very best. Thank you.